When creating a character, applying textures can be as important as modeling the geometry itself. Textures bring richness and the illusion of detail to a character without increasing its overall polygon count. One way to create these textures is by using Autodesk Maya and Autodesk Mudbox together, in which you sculpt and paint finer details onto the mesh and then output them as 2D maps. This movie series covers different ways of sending geometry and textures between the two applications to iteratively build your character. In this example, our character Andrew is ready for texturing. Andrew's head has been detached from his body, and both objects have been UV mapped separately to optimize texture resolution. The same goes for Andrew's hard hat and fully geared tool belt, which have been designed to be animated separately. For more information on UV unwrapping, check out the two-part tutorial on UV unfolding. Andrew's geometry is made of uniformly spread quads to reduce texture warping and distortion. Finally, you'll notice that some extra edge loops have been added in specific areas like the shirt collar, belt, jean cuffs, boots, and so on. This will preserve edge creases when subdividing the character in Mudbox. Since this movie focuses on Andrew's head and body, you won't need his accessories, so turn off their layer. Drag select the entire character and select Send to Mudbox, Send as New Scene. Mudbox automatically opens with all of Andrew's selected components and the camera in the scene. Maya and Mudbox are now linked. You can send data back and forth from one software to the other by clicking the Update button located in the bottom corner of each application. The Object List window contains all sent objects along with their respective materials. Notice that the view in Mudbox matches the one from Maya. Mudbox uses the imported camera by default. To switch to another view, hold down the space bar to display the hotbox. Click the display icon, then switch view, and then the desired view. To sculpt finer details in the mesh, you need to increase its resolution first. Place your mouse cursor over Andrew's body and press Shift-D until you're satisfied with the results. Note that every time you do this, the mesh face count quadruples. Higher subdivisions require more computing power to render, which may in turn slow down your interactive performance. Press W to toggle the wireframe display over your mesh. Press Page Up and Page Down to navigate the subdivision levels. For those of you familiar with Mudbox, you can go ahead and sculpt and paint Andrew so that he looks like he belongs in construction. For those of you less familiar, you can load the Andrew textured file, which represents a more detailed version of Andrew. Before going any further, let's review what's been done. First, a diffuse map was created using the various tools from the Paint Tools tray. Next, a specular map was created to contrast the shiny areas, such as the vest fabric, from those that are matte, like the jeans and boots. Finally, an ambient occlusion map was extracted to capture all the shadow areas. A texture map converts this information into a grayscale image. Unfortunately, it overwrites the diffuse map under it, leaving Andrew looking more like a pale ghost. Instead, change the paint layer's blend mode from normal to multiply. The ambient occlusion map now amplifies the diffuse map by darkening shadow areas such as Andrew's armpits and jean wrinkles. Andrew's head is painted using the same types of maps. In addition to paint layers, a sculpt layer was also created to capture some finer details, such as clothing fabric, wrinkles, fingernails, and so on. This required that the mesh be subdivided to the point where the face count is exponentially higher than the original resolution. If Andrew is sent back to Maya the way he is now, it would result in a very heavy scene that would be unusable by animators. In order to give the illusion of detail without the burden of a heavy mesh, create a normal map to extract this information to a texture. Select Maps, Extract Texture Maps, New Operation. Select Normal Map from the Maps to Generate list. When extracting a normal map, there are 3 things you need to do. Pick the source and target meshes for geometry comparison. Set the method of comparison, and set the output options for the resulting texture. First, select Andrew's body from the Object List window, and then click Add Selected in both Target Models and Source Models. Leave the remaining options at their default values. Set Method to Subdivision, which works best when the source and target meshes both have the same topology. In subdivision mode, Mudbox compares geometry differences between high and low subdivision levels. Raycasting, on the other hand, emits sample rays from the target mesh to detect differences in the source mesh. Finally, set the desired texture resolution, name, and format. Before you click Extract, be sure to enable Preview as Normal Map. This will come in handy soon. The paint layers now feature the newly extracted normal map. Turn off the Sculpt layer and navigate down to the base subdivision level. Toggle the normal map layer to preview Andrew's detailed look on his low-resolution mesh. Go ahead and extract another normal map for Andrew's head. Now that all the textures are created, Andrew is ready to be updated in Maya. By default, the update sends both geometry and textures to Maya. You can also update textures only if you just need to send your paint layers. In this case, the sculpt layers have already been turned off, so let's update the scene. If you don't select anything, Mudbox asks if you want to send the entire scene. Click OK. If any of the updated objects are not at their lowest subdivision level, Mudbox asks whether to send them as is or to send the base level. In this case, you want to send the base meshes only. Back in Maya, Andrew is updated with the newest textures. Turn on high-quality rendering to view the normal and specular maps. Andrew looks a lot more detailed this way, despite his low-resolution mesh. Let's open the Hypershade to take a closer look at the shader network under the hood. When Mudbox sends materials back to Maya, it renames them so they don't overwrite the old ones. This means that every time you update materials from Mudbox, a new shader network is created. This shader network automatically connects each texture map you created to its respective material attribute. Mudbox also sends a reflection map by default. These texture maps actually link to files stored in a unique location within your current project folder. Thus, for every subsequent update between Mudbox and Maya, textures are automatically copied from one folder to another, which prevents any data loss. In the next movie, we'll look at how to sculpt and paint in Mudbox, as well as how to transfer texture maps between meshes with different UV coordinates.